Systematic error tends to shift all measurements in a systematic way so that in the course of a number of measurements, the mean value constantly varies in a predictable way. When a calibration is being carried out from a reference specimen, these systematic errors are corrected. An example would be when a pH meter probe gives consecutive readings that are all too high or too low, and the device is adjusted to show the correct reading. The uncertainty in systematic error lies in how far the measurement shifts from the true value. The more a set of values shift away from the true value, the more inaccurate a measurement becomes, so systematic error is related to accuracy. Before we go any farther, let's recall that a measurement in the laboratory is not made up of one single value, but a whole range of values, so a measurement is the comparison between two ranges, not 2 points. Knowing this, it would then be understandable that the accuracy between a measured value and true value are determined by these ranges and not by points. The measurement will agree with the standard and be considered accurate if the two uncertainty ranges partially, or totally, overlap. The measured value and true value will be discrepant and be considered inaccurate if the two ranges do not overlap. Measurements are either in agreement or are discrepant. There is nothing in between. When the values are determined to be discrepant, we determine how much the difference is by the following equation. Z equals X experimental minus Y standard divided by Y standard times 100. Let's take a closer look at how this works using weight. An experimental weight of 0.8023 plus or minus 0.002 grams is being compared to a scientific standard value of weight 0.8067 plus or minus 0.0033 grams. We see that the ranges of the measurements partially overlap, so we conclude that the two measurements are in agreement. On the other hand, suppose that an experimental weight of 0.8023 plus or minus 0.002 grams is being compared to the value of a standard weight 0.8077 plus or minus 0.0010 grams. We notice that the ranges of the measurements do not overlap at all, so we say these measurements are discrepant. When two measurements being compared do not agree, we want to know by how much they do not agree. We call this quantity the discrepancy between measurements, and we use the following formula to compute it. The discrepancy Z between an experimental measurement, X plus or minus delta X, and a theoretical or standard measurement, Y plus or minus delta Y is Z equals X experimental minus Y standard divided by Y standard times 100. As an example, take the two discrepant measurements, the experimental and the standard, from the previous example. Since we found that these two measurements are discrepant, we can calculate the discrepancy Z between them as Z equals grams experimental minus grams standard divided by grams of standard times 100. Now plugging in the numbers, we have 0.8023 minus 0.8077 divided by 0.8077 times 100, arriving at negative 0.66%. It should go without saying, if two measurements do agree, it is not necessary to compute a discrepancy. That being said, details in a report are important. It should be reported if the measurements do agree, and it should be reported if the measurements do not agree. However, a discrepancy computation should only be reported if the measurements are discrepant. Systematic error summary. Systematic error tends to shift all measurements in a systematic and predictable way from the true value. The uncertainty in systematic error lies in how far the measurement shifts from the true value, so systematic error is related to accuracy. Accuracy is determined by the distance between two ranges, not 2 points. If the uncertainty range of the reference value and the uncertainty of the measured value partially, or totally, overlap, the measurement is in agreement and the measurement is accurate. If the uncertainty range of the reference value and the uncertainty of the measured value do not overlap, the measurement is discrepant and the measurement is inaccurate. The amount of discrepancy between measurements can be calculated by the equation Z equals X experimental minus Y standard divided by Y standard times 100. It should be reported if the measurements are accurate and agree. It should be reported if the measurements are inaccurate and discrepant. A discrepancy computation should only be reported if the measurements are discrepant.